Now the question number 5 is, find the dimensions of the rectangle of largest area having perimeter 120 centimeters. Almost the same question. Here perimeter is given and we have to make area the maximum. You have to form a rectangle containing largest area, but perimeter must be 120 centimeters. So let's start our solution. As the perimeter is given, and perimeter is actually sum of all sides, and in case of rectangle, if one side is x, then that is also x, and suppose that is y, so that is actually y. So let the length of the rectangle is x centimeter and width of the rectangle is y centimeter. So perimeter will become, which is 120, and by formula the formula of perimeter of the rectangle is 2 into length plus width, and length is x and width is y, so we have perimeter 2 into x plus y, and the given value is 120, the given value of perimeter. So from here we can take the value of x plus y is 60, and y will become 60 minus x. Y is equal to 16 minus x. And as the formula of area of the rectangle is x into y, and the value of y is 60 minus x, so we have area is equal to x into 60 minus x, and by simplifying that will become 60x minus x square. Now to form this area function maximum, we have to make our second derivative less than 0 at our stationary points. So for stationary points, we have to make first derivative and similarly second derivative, and put first derivative is equal to 0. First derivative is 60 minus 2x and the second derivative is minus 2. For stationary points, put first derivative is equal to 0, and which is 60 minus 2x is equal to 0, and from here we can get the value of x, which is 30. Now put this x is equal to 30 in second derivative of the area function, which return a negative value, as our second derivative is the constant function. So second derivative is minus 2, which is less than 0, and if the second derivative is less than 0, then function will return a maximum value at stationary point, and the stationary value is x is equal to 30. So we can say area is maximum at x is equal to 30, and already the required condition is to make area maximum. So area will be maximum at x is equal to 30, so put x is equal to 30 in equation number 1 to get the width of the rectangle. So y is equal to 60 minus 30 and y is equal to 30 centimeter. Hence length of the rectangle is 30 centimeter, width of the rectangle is also 30 centimeter. So we can say the dimensions of the rectangles are 30 centimeter and 30 centimeter. Dimensions is actually length and width of the rectangle, so which we calculated is 30 and 30. Now question number 6. Find the lengths of the sides of the variable rectangle having areas 36 centimeter square when its perimeter is minimum. Variable rectangle, that means its dimensions may be changed to give perimeter, to give the area is 36 and whose perimeter should be minimum, and that dimensions of the rectangle. Solution: let length of the rectangle is x centimeter and width of the rectangle is y centimeter. In our question 5, perimeter is given and we have to make area maximum, and in this case area is given and we have to make perimeter minimum. So area is equal to 36 centimeter square, which is a given value, and by formula area is actually product of length and width. So length is x and width is y, so area will become x into y, which is given 36, and from here we can calculate the value of y, which is 36 over x. Now by formula, perimeter is actually 2 into x plus y. This is actually 2 into length plus width, and length is x and width is y, so perimeter will become 2 into x plus y. Put the value of y, so perimeter will become 2 into x plus 36 divided by x. And now to find or to make perimeter a minimum, we must find first derivative, second derivative, stationary points. So first we find first derivative of this perimeter function. Dp by dx is equal to, this 2 is a constant number, will remain same, and the derivative of x is 1, and derivative 36 is also a constant, and derivative of 1 over x is actually minus 1 over x square. So this is actually the first derivative, and the second derivative, 2 again a constant number, the derivative of 1 will become 0, and derivative of 36 over x square, this can be written as 2 into 1 minus 36 x raised to the power minus 2. So this is actually a first derivative. And now to differentiate, this will become 2 will remain same, derivative of 1 will be 0, and derivative of 36 x raised to the power minus 2. So by using our power formula, this will become minus 2 x raised to the power minus 3. So multiplying to 36, that will become 72, and x raised to the power minus 3 can be shifted to the denominator, will become 72 over x cube. And by multiplying to 2, the second derivative is 144 divided by x cube. Now for stationary points, put first derivative is equal to 0, which is 2 into 1 minus 36 over x square. And from here we can calculate the value of x. 2 can never be 0, so 1 minus 36 over x square is equal to 0, and from here by simplifying or by taking LCM, x square is equal to 36, and from here x will become 6. X is actually plus minus 6, but we already know that x is actually the dimensions of the rectangle, which can never be negative, so we only consider the positive value of x. So x is equal to 6. Now put this x is equal to 6 in second derivative, we get 144 divided by 6 cube, which is actually 144 divided by 216, a positive value. And if second derivative returns a positive value, then the function whose second derivative is greater than 0 will become minimum at that stationary point. So perimeter is minimum actually at x is equal to 6 centimeter. So put x is equal to 6 centimeter in equation 1 to get the width of the rectangle. So y is equal to 6 centimeter, and we can say length of the rectangle, which was x, is 6 centimeter, and the width of the rectangle, which was y, and we already calculated the value of y, which is also 6. So dimensions of the rectangle will become 6 and 6.